Okay, so my screen is visible to you all. Is this visible? My screen is visible.
Yes, ma'am.
Yes. Okay. So for task 5, we have to do the project which is heart disease prediction. Okay. So in this project, you have to apply all the skills that you have learned so far. Okay. So basically, all your basics of the data analysis is covered till here. So this is your project. You can also add this in your resume. Okay. So yes, it depends on you. And also you have to apply all the skills that you have learned so far. You basically have to analyze it. Okay. And have to make the proper dashboards, and you have to predict the analysis of this data set. Okay. So now I'll show my screen of your project. See here. So in this, your first task is to import all the necessary libraries into your Jupyter notebook. Okay. So first task is importing all the libraries that we need. So here, first is import NumPy as NP. Okay, which you know is used for the numeric data set. And second is pandas as PD, which is for reading and writing part. Okay, which is for basic function. And third is matplotlib.pyplot as PLT library. In this, all the charts and plots are there. Okay, this is for visualization purpose. Okay, and then fourth is CMON library. This is the advanced library for the plotting purpose. Then comes the percentage matplotlib inline. So what this means, this library is a command used in Jupyter notebook or for data analysis. Okay, like basically it allows you to display plots and visualizations like directly within the notebook interface, okay, rather than in a separate window. So yes, this is the function of this library. Okay, so first your task is to import all the necessary libraries. Then your main task is to import your data set. Okay, so I hope till now you all know how to import your data set. Okay, how to import the CSV file into your Jupyter notebook. So for it, you have to like same have to make a variable name. Okay, here I make the df, then equals to pd.read underscore csv, and inside the parentheses you have to copy paste your location. Okay, so I hope all know till now how to import your data set. Okay, so first we'll analyze our variables and rows and columns of our data set. Okay, so for it, for just taking the reference for the visualization purpose, here we are checking the first 5 rows by calling df.head. Okay, so this function will give us the top 5 rows of our data set. Okay, so these are the columns that are present in our heart data set. So which is like first is age, sex, CP, then this is for cholesterol, this is for target. Okay, so these are the top 5 rows and these are the column names. Okay, so now comes the df.tail function. So what this function will do, this function will tell you the bottom 5 rows. Okay, the bottom 5 rows of your data set basically. So this is your bottom 5 rows. Okay, now we'll take a look at the column names. Okay, so for taking a look at the column names, you have to use df.columns.values. Okay, this function, and here is your all the names of the column part. Okay, then we'll check for the null values. Then your work is for checking the null values. If there is null values, then you have to handle it. Okay, so here there is no null values present in your data set. Okay, for this you have to use is na dot sum. Okay, so here is no null values present, so you don't have to handle it. Okay, so yes, so now we'll do the concise summary of our data set. For this, we have to use info function, okay, information function. So this function will tell you how many non-null counts are there and what is the data type of it. So 1025 non-nulls in all the columns, okay, and all the data types is int, integer, but only except the old pick is float, integer, float data type, okay. So now we'll plot the histogram of all numeric values for just seeing the all columns in the visualization purpose basically. Okay. So we are drawing the histogram of all numeric values. So here is your syntax, which is df dot hist. You know you have to use hist method for plotting the histogram, and here bins equal 50. See here bins refers to the interval or ranges basically. Okay, so here it represents interval or ranges. These are bins. Okay, into which data is divided for analysis or visualization. Okay, it is commonly used in histogram plot to group data points. Okay, now second is like if I'll do here 100, now you'll see the difference. Now you'll see the bin. Just wait for a sec. Now you'll see how the interval and how the interval and ranges will increase. Okay, by the 100. See now your interval and ranges will increase. Okay, so these are the bins basically. Here grid equals to false. Here grid basically refers to the set of evenly spaced lines or dots that form a network. Okay, if you will do now, I'll show you practically what this means. If you will do here true, okay, now you'll see the result, what this will show. See, here these are the grids, okay, in the background, these are the grids, okay. So, if you want the grid part in your visualization, then you can apply your grid equal to, otherwise you can set here false, okay. So, I don't want grid right now, so I am again changing it to the false part, and here I am writing the wins range to 50 again, okay. And this is your figure size 20 comma 15. This is your length and breadth of your histogram, okay. This also you can set by your own, okay. See, okay, this is the length and breadth, this figure size. So here is for the plotting histogram of all numeric values. Now for generating the descriptive statistics, you all know you have to use the describe function for it, okay. So it will tell you how the count, mean, STD, mean, 25%, 50%, 75% max, okay. What is this value of the particular column? So mean of the age column is this, sex column is this, CP column is this, okay, which is chest pain here. So this is your descriptive statistics. So means basically you have to first import all the necessary libraries, then you have to import the data set into it, then you have to check some of the rows, okay, like you have to show some of the rows and bottom rows, okay. Then you have to check for the null values. If there are null values, then you have to handle it. Then you have to show the summary and descriptive statistics, okay. Then you can also show by the visualization purpose. Basically you have to analyze all the variables first, okay, then we'll head towards the visualization purpose, okay. So this all will done, this all are done. So now we'll go upon on the questions part, okay. So basically this questions I have taken here only 4. You have to taken minimum 7 or maximum till 10, okay. So here are the 4 questions. You have to take minimum 7 or max you can go till 10, okay. So yes, it depends on you. Okay, so here you have to solve the question, and then by using the function, then you have to visualize it. Okay, that question. So first of all, we'll solve the first question, which is let's find the answer of first question, which is how many people have heart disease and how many people doesn't have heart disease. Okay, so for it we are getting the values by using the target value. Okay, so in target it will say if it is 1, then it will be heart disease, okay. And if it is 0, then there is no heart disease, okay. So for getting the values, we are using the target column, then we are using the dot value underscore count, okay. We are counting the value of the target column. So basically here 1 represents the people having heart disease and 0 represents the number of people having no heart disease, okay. So this is your answer by your function. Now we'll plot the bar chart of the same, okay. We have to use this same answer, df dot this same answer, then we have to use dot plot for plotting the bar chart, okay. And here kind is bar, okay, and color is orchid and salmon. Here we have set the color orchid and salmon, Okay, and you know how to set the title name, which is heart disease value. This is the title. X label is here, one is heart disease and zero is no heart disease. Then Y label is your amount. Okay, so this is your bar chart. It shows how many people having heart disease, and this shows how many people doesn't have heart disease. Okay, so this is your bar chart for the same above answer. Okay, now we'll plot a pie chart for the same. Okay, so for it you have to use the target value. Okay, then you have to use dot plot, and here kind is now pi. Okay, and this is your figure size. Figure size is this. Okay, you can like change also depending on you. If you change, then I'll show you, but this will show the figure size. See, this is your figure size after changing. Okay, so it depends on you. This is how you can set your figure basically. Okay, I'm changing it again to normal. Okay, and this is your legend, which is disease and no disease. So here blue color represents the people having disease and orange color represents the people don't having any disease. Okay, so this is your pie chart for the same. Now here for the sex column, here 0 represents female, this represents female, and 1 represents male. Okay, and this is for the target column. 0 represent no disease and 1 represent disease. Now let's check how many male and female are in the data set. Okay, so how many male and female are in the given data set. So for it we have to find the value by using the sex column. Okay, for by using sex column you have to, we will conclude that how many people are male and how many people are female. Okay, so by getting it, we are getting the 713 people are male and 312 people are female in our given data set. Okay, means male are actually double the number of female. Okay, now we'll plot a pie chart for the same answer. Okay, we are using the same values. Dot plot kind is now pie, figure size, and title legend. This is okay. So this is your male female ratio pie chart. So male here blue color represents the male part, and female orange color represents the how many people are there in our given set. Okay, data set. Now let's find the answer of our second question. Okay, which is people of which sex has most heart disease. For this we are making the cross tab, which is the short form of the cross tabulation. Okay, so what is this, why we using this tool? Okay, so this tool is for analyzing the relationship between two or more categorical variables. Okay, so yes, for it we have to use cross tabulation. So it will show the relation between the two columns. Here the two columns we are using, which is df dot target and second is sex column, df dot sex. So it will tell you here 0 represents the female part and here 1 represents the male part. Okay, so here and 0 represents no having heart disease and 1 represents having heart disease. Okay, let me confirm first. 0 represent no heart disease, 1 represent disease, and 0 represents female, 1 represents male. Okay, so this is for male and this is for female and this is for no having heart disease and this is for having heart disease. So this is your cross tabulation of these two columns. Now we'll plot the count plot for the same. Okay, so you know how to plot the count plot. This is in Seaborn library. So you have to use sns.count plot. Here X is your target. Okay, this is your target column. X is your target column and data we are taking is df and u is your sex. It means u means it will specify the color, okay, of the two there are two different sex. Okay, so it will specify the two different colors for the both. Okay, for that we can easily differentiate between these two. Okay, like 0 represents the female part and here 1 represents the male part. Okay, so here title is your heart disease and frequency for set, this is your title, and here X label is 0 for no heart disease and 1 is for heart disease. These people having heart disease and these people no having heart disease. So from this chart, we are concluding that number of male is more than double in our data set than female, obviously. Okay, and more than 45% male has heart disease and 75% female has heart disease. Okay, so from our this chart, we have concluded that. Now we'll move to the question 3, which is people of which sex has which type of chest pain most. Okay, So counting values for different chest pain, here you have to use the CP column, okay, chest pain column, dot value underscore count. So here are four types of chest pain, 0, 1, 2, 3, four types of, okay. So here these show the number of people having this kinds of chest pain. Now we'll plot a bar chart for the same, okay. We are using again this function, okay, this function answer, then plot. Kind is now bar. Color we have set the salmon, light sky blue, spring green, and khaki, okay. So this is your basically the color we have set, okay. So here your title we have set is chest pain type versus count, okay. So here the four different colors we have set for the four different chest pain. So this salmon color show the zero kind of chest pain, and the light sky blue color show the blue kind of chest pain, and the spring green color show the one kind of chest pain, and khaki is for third kind of chest pain, okay. Okay, now this is your cross tabulation for the sex column and chest pain column basically. So this will show 0 represents the female part and 1 represents the male part. Okay, so this show your cross tabulation between these two columns. Okay, so now here, okay. So now this is your bar chart for the same our this answer. Okay, so we are taking this answer and we are plotting the bar chart for the same. So here color we have said first is coral, second is light sky blue, third is plum, and fourth is khaki. Okay, and here title we have said the type of chest pain for sex, and X label we have set this. Okay, so it will show you that these are the number of females and these are the males part, that what is the ratio of the female and male, what kind of chest pain they are having most. Okay, so from this visualization we are getting that most of people has type 0 chest pain and least of male has type 4 pain, okay. And in case of female, type 0 and type 2 percentage is almost same, okay. And for male part, the type 0 chest pain and least of male has type 4 pain, okay. Most are the 0 and least are the type 4, okay. So now we'll move towards the question 4, okay. So now we'll move towards the question 4, which says the people with which chest pain are most prone to have heart disease, okay. So for it we are cross tabulation, we are creating the cross tabulation between the CP and target column, okay. So this is your cross tabulation. Now we'll plot the count plot for the same. Here X is your CP chest pain column and data is your DF, Q is your target, okay. So here U is equal to target, it means it will show different color for the different targets, okay. 0 and 1 different color for the different targets. So this is your count plot for the above answer, okay. Now we'll check the most of people. So from this visualization part we are concluding that most of people who has type 0 chest pain has less chance of heart disease, and we see the opposite for the other types, okay. Now let's take a look at our age column, okay. So for the age column we are creating a distribution plot with normal distribution curve, okay. So here we are plotting the DEST plot, okay. So DEST plot is the advanced plot, okay, which is in Seaborn library, and it is the short form for the distribution plot, okay. So like it combines a histogram, basically it displays the distribution of a single numerical value, okay, single numerical value it shows. So and it combines like a histogram with a kernel density estimate. This is your kernel density estimate. This curve represents your kernel density estimate, okay, providing like a comprehensive view of the data distribution basically, okay. So this is your distribution plot. Here you have to take on only one column. Here we have taken the age column, okay, and data is DF, bins is 30. You know what is bins, interval or ranges, and KD is kernel density estimate is true here, okay, means this is true, this curve is true. And if you will do here false, then you will see then you can more clearly know what is KD. See, now the curve is removed. Basically, the KD is removed now. Okay, so that curve represents the kernel density estimate. Okay, so here I am again setting true. Okay, so yes, from this we are concluding that 50 to 59-year-old people are most in the data set. Okay, see, 58 to 59 are most in the data set. Okay, now we'll plot the another distribution plot for maximum heart rate. For this, we are again using the displot function, and here we are taking the thalach column, and data is df, bin is 30, kd is 2, color is chocolate here. Okay, this is your chocolate color and this is your kd. Okay, so from this visualization we get a clear overview about the maximum heart rate represented by a thalach. Okay, so this was all your task 5 analysis of your heart disease data set. Okay, so I am again giving a brief of your project, that what you have to do. Basically, you have to apply all the skills that you have learned so far. You have to import all the necessary libraries, then you have to load a CSV file into it, then you have to show some of the rows top and bottom, then you have to check for null values, and if there are null values then you have to solve it by the three methods that we have learned so far. Then you have to show the concise summary of your data set, then you have to plot the histogram for the visualization purpose of all the columns if you want. Okay, you can also use any visualization. Okay, then you have to show the descriptive text. Then you have to then you have to here take minimum 7 questions, or maximum you can go till 10, then you have to solve it. Okay, by using the function, then you have to plot the visualization purpose with respect to your question answer. Okay, so then you have to plot the visualization and you have to solve the answer, solve the question, then you have to plot your visualization charts or plot. Okay, so this how you have to make your proper, this is how you have to like proper analyze your heart disease dataset prediction. Okay, so this was all your task 5.